Okay, now we will design a dipole antenna by using a Feko software. So just click on the Feko 2025. Okay, so once you click on the Feko 2025, this window will be opened. So now click on the CAD Feko. Okay, so once you click on the CAD Feko, okay, CAD Feko window will be opened. So the CAD Feko window contains so many options. So in those options we use mainly construct, source load option, request option, mesh option, solve or run option. Okay, these options are very important. Okay, so you know how to add the variables. So simply click on the plus symbol. Okay, add variables. Okay, so here we have to add the length of the antenna L, and frequency range is f minimum, f maximum, and radius of the wire. If you want to add the length, so simply delete the variable 1 and write L. So in place of expression, write the length of the antenna, that is 0.059. Simply type 0.059. So this will be calculated from basic formula. Okay, now just click on the add. Automatically length will be added here. Similarly, you add the f minimum, f maximum, 2 GHz, 3 GHz. Okay, and next radius of the wire 1.5 mm, 1.5 into e power of minus 3 here we are taking. Okay, so now you have to design the dipole antenna. Here we will design a dipole antenna. Dipole antenna is simply nothing but it contains two simple wires. Okay, so in those options where different shapes will be available, simply click on the construct window. So in construct window we have different type of shapes. Okay, now click, we need a wire because dipole is nothing but a two simple wires, bottom wire and top wire. Okay, just simply click on the line 1. So these options will be available, U, V, N. These are nothing but X, Y, Z. If you see in X direction U is available, Y direction V is available, Z direction N is available. So simply you can name as U, V, and axis. Okay, so you make all these axes 0, U0, V0 and 0, and coming to the end point make U0, V0, and coming to the end we are creating the upper part of the wire. Okay, and we know the total length of the dipole is capital L, so we are taking L by 2. Okay, now create. So automatically line will be added here. Okay, one line, one copper wire will be created here. Now we have to create at the bottom of the coordinate system. Okay, so for creating the another wire, simply click on the line. Okay, all are same, U0, V0. Okay, and what about the length? That will be considered as a L by 2, but you have to create in a reverse direction. So you are making minus L by 2, that is line 2. Okay, so automatically line 1, line 2 will be created. Okay, this is one wire and this is another wire. Okay, you can see. So in Feko we have so many shortcut keys are available. Okay, see, these are the shortcut keys. View, if you press F1, okay, F5 is there, 0, 2, 4, 5, depending on the number we are getting different views. Okay, suppose if I click on the 0 button, if I click on the 5th button, the appearance will be changed. 6th button, the appearance will be changed. Okay, if I click on the 0, original shape will be appeared. Okay, so the view can be changed by using number keywords. Okay, so those are available in Feko shortcut keys. Okay, 3D views, these are all 3D views. Now go to Feko. Simply we designed upper wire and lower wire. So if you click on the F5, automatically perfect view will be available. Okay, now for any antenna we need a port. Okay, so see, this is a simple dipole antenna. So in between the dipole antenna we are using a feed here. Okay, in Feko software also we have to connect this feed. So before connecting this feed we have to give the port 1 and port 2. Okay, so we have different type of connectors available. Okay, SMA female connector, male connector. Okay, these are all ports, simple ports. Now you have to give these ports in your design. So for creating the port, simply click on the line 1. At the details we have, see what is meant by line 1, that is a simple wire. Okay, now right click on the wire, create port, and click on the wire port. Okay, so where we have to create the port? Exactly for line 1 starting point. Okay, so here we have so many options, middle, and if you click on the middle option, then the port will be appeared at the middle. If you click end option, the port will be appeared at the end, but we need at the start point. Okay, so simply click start, add, okay, and close. So here port will be created for line 1, and for line 2 also we have to create the port. So click on the line 2, go to details. Okay, in wires, wire 4 option will be available. Right click, create port, wire port. Okay, so for bottom port we have to create the port in a reverse direction. So click on reverse polarity. Okay, so for one port we don't click on reverse polarity, for another port we are clicking on the reverse polarity, and next create. Okay, so see, two ports will be created, wire port 1, wire port 2. If you click on the geometry line 1, okay, these options will be available. Okay, so finally here we are creating the two ports for upper line and bottom line. Okay, so after creating the ports, we have to add the frequency range. So from which frequency to which frequency we have to run your simulation. Okay, for that purpose go to source load option. Okay, so in source load option we have the frequency option is there. So click on the frequency option. So we have the single frequency, remove that single frequency and please mention linearly spaced discrete points. Okay, and what is the starting frequency? We already mentioned F minimum. What is the ending frequency? We already mentioned F maximum. And what is the range we have to taking? 100. We can take 200, 300. Okay, 100 points I am taking. Okay, apply. Okay, so automatically in configuration window, global frequency range will be added. Okay, now we have to add the sources. Okay, so you know already for any dipole antenna you have to excite. Okay, now we only created ports, so for exciting those ports we need a source. So in Feko software we have the voltage source option is there. Now go to construction line 1. Okay, corresponding port wire port 1, click on the wire port, right click on the wire port 1, voltage source. So here I am giving magnitude 1, phase 0, reference impedance 50 ohms. Okay, name will be voltage source 1. Please add simply single time. Okay, automatically voltage source will be created. See here, if you go to the configuration window, bottom of the sources voltage source 1 will be appeared. Previous there is no voltage source 1. Okay, so first you have to check whether you have added frequency range and you connected voltage source. After these 2 points are completed, okay, now go to request. So in request window, far field is there. Click on the far field. Okay, azimuthal angle, elevation angle, everything will be available here, theta phi. Now click on the 3D pattern. Okay, so now for getting the radiation patterns of the antenna we need a 3D pattern. Okay, so after clicking on the 3D pattern, simply click on create. Okay, automatically far field setup will be completed. After completion of the far field setup, go to mesh and click on the modify mesh. Okay, here give 5 e power of minus 4. Okay, and apply, and then mesh arrangement is completed. And then go to the solver run, and here click on the Feko solver. Okay, don't click on post Feko, edit Feko, just simply click on the Feko solver. Okay, so it will ask the in which name you have to save. Simply click dipole antenna. Okay, and just save in a corresponding folder. It will runs. If any mistakes or errors are available, then it shows in the executing run Feko window. So there is no mistakes, so it shows finished. After completion of finished, click on the post Feko. Okay, once Feko solver completed, then click on the post Feko. Okay, once post Feko is clicked, then here we can see the results. So what are the results available for any antenna design? We can see the radiation pattern, we can see the VSWR, reflection coefficient, gain of the antenna, directivity of the antenna. Okay, so now we will check the simple VSWR. Okay, so here first I will check the VSWR plot. So for getting the VSWR plot and reflection coefficient plot, just click on the Cartesian, okay, Cartesian option. So once you click on the Cartesian option, here Cartesian graph 1 will be appeared, but here there is no graph. So for getting the graph, go to source data, okay, click voltage source 1. Now you can see the VSWR plot of your antenna. Okay, so this is a reflection coefficient plot. If you want to get the VSWR plot, go to quantity, make VSWR. Now we can see the VSWR plot. Okay, so if you want to get reflection coefficient, then you can click reflection coefficient. Okay, then you can see the reflection coefficient. So the reflection coefficient must be in dB. So just scroll down the mouse, you can see here dB option is there. So just click on the dB option. So then reflection coefficient is in dB. Okay, so if you can add cursor also, just click on the cursor. Okay, now move or drag this cursor. See, at approximately 2.37 gigahertz, you are getting reflection coefficient minus 15.5 dB. Okay, the reflection coefficient must be less than minus 10 dB. So here we are getting minus 15 dB. Okay, at your operating frequency. Now if you want to get VSWR plot, simply change reflection coefficient to VSWR. Okay, and don't use dB. Okay, see, at your operating frequency 2.37 gigahertz, we are getting 1.3 approximately VSWR. So VSWR must be equal to 1, then only that is a good antenna. Okay, so it's okay, you are getting 1.39, that is closely equal to 1.1, closely equal. Now see here, take this frequency at 2.1. what is the VSWR here? We are getting 3, so the losses will be very high. So if VSWR is less, means you are designing a good antenna. So at 2.3 gigahertz we are getting 1.4 VSWR. Okay, so that means your antenna is operating at 2.3 gigahertz. Okay, now if you want to see the radiation pattern, how you see the radiation pattern? Okay, now click on the dipole antenna 1. Okay, your antenna is showing here. Okay, click on the far field and again click on the far field 1. See how the antenna is radiating. Okay, so if you want to see, you want to get in dB, simply you can click dB. So the radiation of the antenna will be like this. Okay, at what frequency you are operating your antenna? 2.4 gigahertz. Okay, so here change the frequency to approximately 2.4. Okay, so this is your operating frequency and you are showing your radiation pattern in dB. Okay, so this is the radiation pattern of your dipole antenna. If you want to see the polar plot, that is the option is also available. So simply click on the polar. Okay, simply click on the polar. Here we are not showing anything. So go to far field and click on the far field 1. You can see the radiation pattern, 2D radiation pattern. Okay, in both direction, if you want to need, go to independent axis and change to theta wrapped. Then you can see the radiation pattern of the dipole antenna in polar form. Okay, so here also we can change the dB. Okay, then this is the radiation pattern of your antenna. Okay, 2D plot. So like that we can see the 3D view, 2-dimensional view, VSWR, okay, S11, different parameters by using Feko software. Okay, thank you.